So in this section, we are going to learn how to solve quadratic equations by completing the square. We've already learned the square root property in the past, so we're going to use that where we remember to put in the plus or minus and taking the square root of both sides. So we're going to use, if the equation looks something like this, where we have ax plus b quantity squared equal to c. So to solve by completing the square, it's the process of writing a quadratic equation so that one side is a perfect square trinomial. And those look something like this. So if we have something like x squared plus 8x plus 16, we get x plus 4 quantity squared. X squared minus 6x plus 9 would be x minus 3 quantity squared. X squared plus 3x plus 9/4 would be x plus 3 over 2 quantity squared. We're going to find the constant that results in that perfect square, and to do that, when it's in a form like this, we're going to use b over 2, so we'll take the b term, divide by 2, and then we will square it. And there are some steps for solving quadratic equations. If the coefficient of x squared is 1, we just go down here. If not, you have to divide both sides by the coefficient of x squared. So divide everything by a. You want to isolate the variable terms on one side of the equation. That means we're going to move our c value over. You'll see this as we go through. And then you can complete the square for the resulting binomial by adding the square of half of the coefficient of the x, which is the b, over 2, to both sides of the equation. We'll factor it, and we'll use the square root property to solve for x. All right, so I have an example. I did not create this example. I found it on the internet. So if we have an example of x squared minus 10x plus 22 equals 0, the first thing we'll do is isolate the constant. So we move the 22 over, so you have just the x's. And then we have to figure out what do we have to add to both sides to make this a perfect trinomial, or a perfect square trinomial. So we take b, which is negative 10, divide by 2. That'll reduce down to negative 5 squared, which will be 25. So then we add 25 to both sides. So on this side, we can now factor this as a perfect trinomial. And remember, this is equal to negative 5. We end up with x minus 5 quantity squared. 25 minus 22 is 3. We then can take the square root of both sides. We get the plus or minus, so it's plus or minus 3, and then move the 5 over. Same thing would happen down here. We have x squared plus 5x equals to negative 2 after we isolate our variable. What are we going to add to both sides? Well, we have b divided by 2, so that's 5 divided by 2 squared. So that gets us 25 over 4 added to both sides. So this becomes our perfect trinomial, our perfect square trinomial. So the 5 halves that we have here is what ends up being your factor. You have to get this to a common denominator, so negative 8 over 4 plus 25 over 4. That ends up being 17 over 4. And then we take the square root of both sides. So we end up with x plus 5 halves equals plus or minus that square root of 17 over 4. Break this up into the square root of 17 over the square root of 4, and you end up with plus or minus the square root of 17 over 2. And then move your 5 halves over, and you have a common denominator. Let's put them all together. So that kind of gives you an idea of the process. We're going to actually work some out, but I wanted to kind of show you the process of what we're trying to do here. All right, so let's remember that square root property first, because we're going to use it. So this is just kind of a reminder. If I have x squared equal to 9, both sides, I get x is equal to square root of 9, which would be x is equal to plus or minus 3. So this is where we're going to be using that kind of process on both sides. All right, so if we have something like x plus 1 quantity squared equal to 12. Again, I can take the square root of both sides, and I get x plus 1 equals plus or minus that square root of 12. So the square root of 12 is 4 times 3, which is 2 times 2. So 2 times 2 times 3, looking for a group of 2 because it's the square root, we get 2 square roots of 3. So now I have x plus 1 equals plus or minus 2 square roots of 3. Subtract my 1 over, and I get x equals to negative 1 plus or minus 2 square roots of 3. So that's using our ability to use our square root. So now we're going to actually do some our square root property. We're going to look at some of the problems. The first thing we're going to do is find the constant that results in a perfect square trinomial. So on our first problem, we have x squared plus 10x plus, and we need to fill, 10x, not 10, just 10. So we need to fill in the blank here. So this is where we're going to take our b divided by 2 and square it. Our b is equal to 10 divided by 2 squared. That'll get us 5 squared, which is 25. So we'll have x squared plus 10x plus 25. Now, we want to do the factor part. So when we're factoring, we don't have to do our AC method or anything. We know this is a perfect square trinomial because of the process that we did. This is why it's called completing the square. So we know it's going to be something like this. We know that we'll have an x because I just have an x squared up there. And this part right here, this is the part that will become the part in here. So it's plus 5. And you're done. You don't have to do all of the factoring because of the type of problem this is. All right, let's do another one. So if we have p squared minus 4p plus blank. So again, b over 2 squared will get you negative 4 over 2 squared. Well, negative 4 over 2, that's negative 2 squared. Negative 2 squared will get us 4. So we have p squared minus 4p plus 4. And then we need to factor it. So the factor part, again, something like this. We know that we have the letter p. This number right here, that negative 2, is what goes inside. So p minus 2 quantity squared. All right, so the next problem that we're going to do, we are going to actually solve by completing the square. All right, so on this case, we have p squared plus 2p is equal to 4. So what we need to do is figure out what are we going to add to both sides. So we need to figure out that number. So we're going to take our b over 2 and square it. So we'll have 2 over 2 squared. That equals 1 squared, which is equal to 1. So we have p squared plus 2p plus 1 is equal to 4 plus 1. You have to, what we do to one side, we still have to do to the other. So we end up with p squared. Oops, what we can do, we'll factor this side. Sorry about that. So we'll have p, that's our number that goes in there. So p plus 1 quantity squared. 4 plus 1 is 5. So now what we'll do is we'll come in and we'll take that square root of both sides, and we end up with p plus 1 equals plus or minus the square root of 5. Subtract 1 from both sides, and we get p is equal to -1 plus or minus the square root of 5. So this would be the solution in completing the square, and we're using the steps that we used in the previous problem. All right, so let's go look at another problem. So if we have m squared minus 7m minus 1 equals to 0. The first thing we have to do is isolate our m's. So we're going to add the 1 to both sides and get m squared minus 7m is equal to 1. So again, we're looking what we need to fill in that spot right there. So our b over 2 squared, our b is negative 7 over 2 squared. That won't reduce, but when we square it, we get positive 49 over positive 4. Because we're squaring both terms, so you'll always add a positive value over here. So m squared minus 7m plus 49 over 4 equals 1 plus 49 over 4. This we will factor, and so this will factor to be our m minus 7/2. Because we're just going to use that value. All right, now we need to add this. Well, this would be, we need this to be a 4 common denominator. So if we look at 4 fourths plus 49 fourths, that'll get us 53 fourths. So we're just getting that common denominator right there. So it'll be equal to 53 over 4. We'll come in and take the square root of both sides. And when taking that square root, we end up with m minus 7/2 is equal to plus or minus the square root of 53 over 4. So now let's reduce this down. Remember, this is the same as the plus or minus that square root of 53 over the square root of 4. We've learned this before where we can separate the radical out. So this will get us m minus 7/2 is equal to plus or minus that square root of 53 over 2. So we end up with that square root of 4 being equal to 2. Now we'll add the 7/2 to both sides and get m is equal to 7/2 plus or minus the square root of 53/2. Well, those have the same denominator, so m is equal to 7 plus the square root of 53 all over 2. And that would be our final answer for that problem. All right, so let's do a problem where we don't have a 1 in the front of our variable. So I'm going to pull out a new sheet so that we can have enough room to work the whole problem. So we have 2x squared minus 8x plus 3 is equal to 0. So if we don't have a 1 out front, we have to divide each term by 2. And we have to do it to both sides. So now we have x squared minus 4x plus 3/2 is equal to 0. So let's move our 3/2 over. And we have x squared minus 4x is equal to negative 3/2. So again, we're looking for the part that we have to add to this to get our perfect square. So we're at the b over 2a. So b is going to be, and we got to square it, negative 4 over, not 2a, so sorry, over 2. I'm thinking about quadratic formula. Sorry about that. Negative 4 over 2 squared. Well, negative 4 divided by 2 will get us negative 2 squared will get us a positive 4. So we have x squared minus 4x plus 4 equal to negative 3/2 plus 4. So with our factor, we're using our reduced part here. So this side will factor to be x minus 2 squared. So here we have negative 3 halves. We need to put 4 over 2. This will be 8 halves. So you can do it off to the side or you can do it in the equation. I know in the last problem we kind of did it off to the side, but I'm just showing you options of the way you can work it. So we have x minus 2 squared equals to 8 minus 3 will get us 5 halves. And again, we'll take the square root of both sides. We have x minus 2 is equal to plus or minus that square root of 5 halves. So we are going to have to separate this out. So x minus 2 equals plus or minus that square root of 5 over the square root of 2. It's not a perfect square this time, so we're going to have to figure out what we need to do, and that is rationalizing the denominator. So square root of 5 over the square root of 2, we're going to multiply by the square root of 2 to the numerator and the denominator. Square root of 5 times the square root of 2 will get us the square root of 10. Square root of 2 times the square root of 2 is that square root of 4. So square root of 10 over 2. So this will come back down here. So x minus 2 equals plus or minus the square root of 10 over 2. And again, you could work it all down here. I'm just choosing to work it off to the side, so I'm not kind of losing the process of our equation here. All right, so now I just got to add my 2 over. So our x would be equal to 2 plus or minus the square root of 10 over 2. Now, we want to put this over a common denominator, and 2 would be 4 over 2 plus or minus the square root of 10 over 2. So we're just transforming 2 over 1 to 4 over 2 to have that common denominator. So x would be equal to 4 plus or minus the square root of 10 over 2. And that would be our final answer. And that is how you complete the square.